problem. So if you are taking your own notes, that's f of x equals, we have a 2x minus 5 squared and then minus 4. So what you guys should have seen yesterday in your homework is that only stuff that was happening in here before we squared the function, that's our horizontal transformation stuff, meaning it was changing the x coordinates of your graph somehow. It was adjusting those, okay? Everything that happened after the squaring was done, those changed your y coordinates, okay? So we want to think about how we're going to make a table for what these transformations are. So last night in your homework, again, you kind of only did one at a time. So if it was just x minus 5, you should have added 5 to the x coordinate, but kept the y coordinates the same from the parent function. Okay, if just the 2 was here, you kept the x coordinates the same and you multiplied the y coordinates by 2. Just the minus 4 was here, you kept the x coordinates the same, and then you subtracted 4 from the y coordinates. So I want you to take a couple minutes and think about if you guys can figure out in your groups what the ordered pairs are going to look like for this function, okay? So let's give you guys, so we have the parent function and how it works right here in this table with these values. Negative 2 matches 4, negative with 1, etc. Okay? How is this function adjusting the x's? What is happening horizontally or to the x coordinates?
Since it's in the parentheses, you do the opposite.
Good. So this says x minus 5, but remember we talked a lot yesterday about how the x and the minus are part of the formula. The h value, the number you're pulling out, is the number that's after the minus. So if this minus is already part of the formula, the number after the minus isn't negative 5, it is positive 5, okay? So this is like an h value of positive 5. That is the only thing that's going to affect the x's because it is the only operation you would do if you plugged a number into this function before you did the squaring part, okay? So only the stuff that happens inside the function before you actually do the function adjust the x value. So all the x values are going to get changed by plus 5, and that is all, okay? Which means my column of x values used to say negative 2, negative 1, 0, 1, and 2. And now what I'm going to do is I'm literally just going to add 5 to each of those values. And so my new x coordinates are going to be 3, 4, 5, 6, and 7. So is that part okay with everybody? All right? Okay. That's the only thing we would do there because that's the only thing that happens before the function part happens, the mathematical operation that you're doing of squaring. But after you plugged a number in here and you finished squaring it, what would you do to it and in what order? So I plug a number in here, I do whatever, I square it. And now you would do what? So after this part of the function is done, and you have a number there, what's going to happen to that number, Travis? You would multiply it by 2 and then subtract 4 because of how order of operations work, right? That means our y values, the numbers that became after the squaring, would be multiplied by 2 and subtracted by 4. And in that order because that's the order of operations. So what used to be our y value is now going to get times by 2 and subtracted by 4 because of what showed up in our function. So we're going to take all the y values that used to match up with these points. We're going to take those values and do these operations to them. So it used to go 4, 1, 0, 1, 4. But now each of those things is going to be times by 2 and subtracted by 4. So everything that you can do on a graph, you could do numerically to the points that already existed in the parent function. Okay? So 2 times 4 is 8, minus 4 is 4. 2 times 1 is 2, minus 4 is negative 2. And we would just keep doing this. Yeah. That's only if the 2 was in the parentheses with x. And we haven't done any of those in here yet. Yeah. I know some of you guys have experience of doing that. And so we're not doing that yet. We're going to do it in functions where that matters a little bit more. Technically, in all of these, you could transform that into a vertical thing instead of a horizontal one. Where it will matter is when we do like sine and cosine waves, and we're changing like the period. And so we're going to save that for something where it matters a little bit more. Okay, because these numbers, we're using this chart, right? And this chart already expresses the number being squared. So because we already have the parent function that did the squaring, we just have to adjust the numbers here before they were squared and the numbers here afterwards by the operations all surrounding the square or inside the square. If we just made our own t-chart and plugged in values just randomly, we would go through every operation. But because we're already using the parent function, the relationship of squaring is already existing right here. And then we're just changing it based on these other numbers here. So this is something that we have memorized and we're familiar with because it's our starting point for all of these. And then we're just changing them using this pattern here. Is that okay with everybody? So now we're going to put these new points on the graph. And by new points, I mean your adjusted x coordinate with your adjusted y coordinate. So I don't graph negative 2, 4 anymore. Instead, I graph 3, 4, because that's what they were after they were adjusted by everything that was here in this function. Okay, so I'm going to plot 3, 4. I'm going to plot 4, negative 2. I'm going to plot 5, negative 4, and then 6, negative 2, and 7, 4. And in these transformations, you should see the things that you do grasp onto from Algebra 2. Okay? One of the first things that you should be able to see is that your vertex matches up. You should know if you did this right, if your vertex matches up. So our vertex used to be 0, 0, okay? That point has now been transformed to be 5, negative 4. Should the vertex be 5, negative 4, looking at the numbers in the equation? Does it make sense that our vertex is 5, negative 4? Yeah, okay? 5 from our h value, negative 4 from our k value. So our hk, or our vertex in this case, is 5, negative 4. So then I kind of get some confidence that I did it right. Secondly, does it look like a parabola? Does it have the symmetry that it's supposed to have? That's good. So things seem to be matching up algebraically and graphically. And then besides the 5, negative 4, this 2 was out here. Does this graph seem to have the effect it should have if there's a 2 out here stretching the graph vertically? Does it look like it's stretched out from the original parent function? Yeah, as you go further, things are a little bit further away than they used to be, right? So it seems to look right. For the intercepts, we're going to come back and do those later. Okay? I know that my intercept is somewhere between 6 and 7, and there's another one between 2 and 3, but I don't know exactly what they are without doing a lot of solving in this problem, and we're going to emphasize solving at the end of this. We're just going to focus on the graphing with the transformations right now and the graphing parts. So we're going to leave these x and y intercepts for later. Okay? What's the domain of the function? All real numbers. Okay? Or in interval notation, from negative infinity to infinity. What is the range of this function specifically? Y is greater than or equal to negative 4. So your vertex point in the parabolas is either your lowest or your highest all the time. So that maximum or minimum value is really going to dictate your range. So here we see all the y values above or at negative 4. Or in other words, our range goes from negative 4 until infinity. What is our increasing interval? Thinks they can tell us that from yesterday. Let's do this. Let's pause for a minute again because we went through this stuff yesterday, right? See if you guys can answer the rest of these questions right here. So leave X and Y intercept. We're going to come back to them. See if in your groups you guys can fill in the increasing interval, decreasing interval. Is it 1 to 1? That's a yes or no. Okay. What's the axis of symmetry? What's the maximum value and the minimum value? Abigail? Okay. Yeah. So the bracket is saying you actually hit that value as part of this thing that you're naming. So when I put the bracket by -4, it means -4 as a number is part of my range. The reason I don't put that for infinity is I can't actually reach the number infinity. Okay? All right. So take a couple minutes in your group. Okay, who can tell us something that they know about the function? Any of these things that you feel confident in sharing with us? Yeah, but okay. So it is not 1 to 1. So remember, to be 1 to 1, you have to be a function and kind of the reverse of what a function says. Every x can only go to one y, and every y can also only line up with one x. So it not only has to pass the vertical line test, but also a horizontal line test, so to speak. Okay? Something else that we know. Vanessa. Negative infinity to what? Okay. So you have the right idea. This is why we split it up yesterday. This is super hard. You have the right idea, but we have to name it just in domain values. Okay? So which part of this graph, as we move across, the first thing we hit is in an increasing or decreasing interval? Left to right, that's decreasing, right? And then we hit the vertex point where it changes direction, and then the rest of the graph is increasing. But remember, when we name them, we have to name them according to the domain, the x values across the graph where this is happening. So if this is the, let's see, we were talking about increasing. So if this is the increasing interval, what are the domain values for which that has happened? Which x's on the x-axis line up with this thing that you have called increasing? Okay. Yeah, so not -4 because we're not naming y values. We're saying which part of the domain on the x-axis lines up with everything you're calling increasing. So instead of looking from here to here, it's increasing and thinking about it vertically, you want to tell me, as I was reading across the graph, across the x-axis, I called it increasing from this point. Oh, no, sorry. Oh, it's right, but I plotted it wrong, right? 5. Here, I'm going to go like this. Oops, not like that. I counted wrong? Yes? Yeah? Can I just change where my x-axis is? You guys understand? Yeah, okay, thanks. Or my y-axis. I'll be a cheater. Sorry. Okay, so there's my y-axis. Here's my x-axis. Now is it in the right spot? 1, 2, 3, 4, 5. Yes. Okay. All right, so I have my vertex here. I get that you guys are saying the increasing part goes from -4 to infinity. Those are the maximum, minimum values that you're talking about. But when we list the increasing interval, we're saying domain values. As I read across the graph from left to right, as I travel across the x-axis, the graph is considered increasing from this x value until this other x value. Okay? So the increasing part of our graph takes place from 5 until forever, okay? So your guys' ideas are right, but the way we write it is from 5 to infinity, and you might want to make a note again. We're specifically listing the domain, or we're listing that in terms of x values, not y values, okay? And then do we use any brackets for our increasing, decreasing intervals? No. Okay. Even 5 we don't include, so why don't we include 5? 5's on the graph, I totally get that. Why doesn't it get to be called part of the increasing interval? Travis? Yeah, you can. But this one, because they say interval, you should use an interval. So this one we're going to have to use intervals, and these ones you guys can have a little more freedom. Is that all right? Okay. So why isn't 5 included? Yeah. Good. It's a turning point. What's happening at the turning point? Are you part of the increasing? Are you part of the decreasing? It's neither. It's like your resting spot where you're not sloping up or down for 5 seconds, okay? Just take the rest. But that means we can't include it inclusively in either one because it's not technically part of either. It is a turning point. It is the one place where you wouldn't be on an incline or a decline. You would just kind of be flat for a minute, okay? All right, so who thinks they can name our decreasing interval properly? Yeah, good. Good. From negative infinity to 5. Okay. So the decreasing part of the graph was this part right here. But remember, I want to say it as I'm moving from left to right, the graph is decreasing when the x's are, and basically forever to the left until 5. So forever from the left until 5. Okay. Is that all right? So I know that's hard. So again, there's kind of two parts. Try to separate it for yourself. You want to be able to visually look at the graph and understand which part is increasing and decreasing. But when you go write it, you really have to think about which x's line up with the increasing part, which x's line up with the decreasing part. And that's what they're talking about there. Yeah. Yeah. All right. Axis of symmetry. Who's confident that they have the axis of symmetry? How do we go? It is 5. Good. And so how are we going to name it? X equals 5. Yeah. Okay, so we have to make sure that we understand it's the vertical line at 5. So again, you guys are totally right in identifying it's at 5. And when I'm talking about it up here with you, I know what you mean. But like on the paper, if you just write 5, we don't know what you mean unless it's labeled like this. All right, minimum value. It is -4. And that one is just -4 because the question is asking you for a value, which is one single numerical value. Okay? And that refers to the y's. It is like, what is the top y that you reach, or what is the bottom y that you reach, maximum and minimum value. What is the maximum value? Okay, so it goes towards infinity, but since it wants an exact number and infinity is not that, we just say none. Okay? It's all right with everybody? Okay, so your homework tonight is going to be like last night, except for your charts are going to be a little more complicated to get the points because now you have more than just one thing happening, okay? You probably only have one thing happening in here because that's all we studied, but you could have multiple things happening out here. Is everybody okay with how we obtained the points to get the graph? Okay, so that's what you're going to be working on tonight. So I will put up the 8 problems that you guys will be doing, and you guys can